This is Calculus Explorations Part 5, More Limits. Last time we looked at limits as we approached a point from the right. And in particular, we looked at the function cosine pi x and asked what happens as x gets closer to 0 from the right, and noticed that as x gets close to 0 from the right, cos pi x gets close to 1. And we saw this by reasoning that for whatever narrow band we put around y equals 1, we could find some value x, so that if our actual value x was less than this value, y, cos pi x, was within our band of 1. And we looked at this formally as the limit as x goes to 0 from above of cos pi x equals 1, but let's generalize this. Instead of cos pi x, let's talk about any function f of x. And that function f of x might not be going to 1, so let's say it's going to some y value, say y sub 0. And instead of always looking at x going to 0 from above, let's go to some other value of x, call it x sub 0. And so we're looking at the limit as x goes to x sub 0 from above of f of x equals y sub 0. And formally that means you choose epsilon. You choose how close you want to be to the y value. I can find a delta so that when x is between x sub 0 and delta, f of x will be within epsilon of y sub 0. So that's the limit of f of x as x goes to x sub 0 from above. What about x going to x sub 0 from below? We'll go back to our cos pi x function, and to visualize this, I've just flipped the graph about the y-axis, but you can see what happens as x goes to 0 from below of cos pi x. It again gets closer to 1. Pick any narrow band around y equals 1, and you can find an x value so that when x is to the right of that value, cos pi x is within that band of 1. And so again, formally, the limit as x goes to x sub 0 from below of f of x equals y sub 0 means for any epsilon you choose, I can find a delta so that if x is between delta and x sub 0, and this time we're to the left of x sub 0, then f of x is within epsilon of y sub 0. So that's the limit from the left and the limit from the right. What about the overall limit? What do we mean by the limit as x goes to x sub 0 of f of x? Well, first, the limit from the left and the limit from the right have to exist. And in our specific example, we saw the pictures that they do. And the second condition is that they have to be equal. For there to be an overall limit, the limit from the left has to equal the limit from the right, and now I can say the limit as x goes to x sub 0 of f of x equals y sub 0. And we can visualize this by drawing some narrow band around y equals 1, or y equals y sub 0 in this case, and we'll be able to find some distance on the x-axis so that when we're within that distance of x sub 0, f of x will be within our band of y sub 0. A limit has nothing to do with the actual value of f of x. A limit is a prediction. A limit says, well, what do we think f of x sub 0 is? The limit as x goes to x sub 0 of f of x is y sub 0 if both the limit from the left and the limit from the right exist and they both are equal. So a limit is a prediction, and last time we saw this function cos pi over x, and as x gets close to 0, it wiggles faster and faster. We can't possibly make a prediction. The limit from the right doesn't exist, and the overall limit doesn't exist. Contrast that with our current function, cos pi x. As x gets close to 0, cos pi x gets close to 1. And we see that on the left side and on the right side, and we saw that overall. We can confidently make the prediction that as x gets close to 0, cos pi x is getting close to 1. And next time, we'll ask the question, what if the prediction is or isn't accurate?